In this video, we're going to be taking a look at a collision problem to find the maximum compression of a spring after this 3 kilogram and 1 kilogram cart collide with one another. So for this problem, we're going to have to use some momentum and energy concepts. And usually when you're implementing those two different things, anytime you have some sort of collision, you can use momentum to help you find masses and velocities. But then in addition, to a problem that's slightly more complex like this, you're going to have to use some energy concepts as well. So let's take a look at the conservation of momentum first, which means the sum of all the momenta before and after the collision are equal. So let's go ahead and set that up and see what we come up with. All right, so I set it up as a perfectly inelastic collision, as if these two were connected to each other after the collision. Now, there's something that you have to realize about this collision is when these two things collide, the spring is going to slowly compress, well, actually kind of quickly compress, but let's think about it in slow motion. So it's going to slowly compress until it reaches its maximum compression, and then the spring is going to start to expand, and then the carts would eventually separate. Now, our goal is to find the maximum compression. Now, at that very specific moment, your spring is pretty rigid because it's pressed in as far as it possibly can. So, for that moment, these two are connected by the spring, and the spring isn't expanding or compressing at that moment. So, they're traveling at the same velocity for that split second. So we can consider them one big 4 kilogram mass afterwards, just at that particular moment. So we have the momentum of the 3 kilogram cart, the 1 kilogram is at rest to begin with, and then afterwards their masses combined, and their combined velocity comes out to 1.5 meters per second. Now, in addition to that, we're going to take a look at everything in terms of energy. Now, we have a few different types of energy going on here. We have the kinetic energy of the 3 kilogram cart at first, and then that seems to be all that we have for initial energy. So then if we're using the conservation of energy, we have some energy after the collision, which would include the kinetic energy of the carts combined. So I'll put kinetic energy for the 4 kilograms total, and then also some elastic potential energy as well, because that spring is going to get compressed. So let's go ahead and use our kinetic energy and elastic potential energy formulas, plug in everything we got, and see if we can come up with that maximum compression. All right, so we found our maximum compression to be 0.082 meters, so we don't have too much compression there. So we have the kinetic energy of just the 3 kilogram cart with the 2 meters per second of initial velocity after the collision, when the two carts are connected with the spring compressed completely temporarily. We have 1/2 times that combined mass of 4, and that 1.5 that we currently or previously got, over here. And then plus the 1/2 kx squared, the elastic potential energy formula. So if I went ahead and subtracted the 4.5 from our K4 from both sides, that would leave us with an additional 1.5 joules that weren't accounted for with kinetic energy, which is the elastic potential energy. That I set equal to 225x squared, because 1/2 times 550 gives it a coefficient of 225, divided both sides by 225, and then found the square root of each side. So when working on a problem like this, as I said before, you're going to take that collision portion of it and use that to find masses or velocities. In this case, it was a velocity, which helped us then be able to execute our energy formulas, and specifically our K4 over here. And then once we found the difference in our kinetic energies, that extra energy was accounted for by the elastic potential energy, which was eventually this blue part over here, 1.5 joules equals 225x squared. And that allowed us to find the maximum compression of the spring. So I hope that was helpful to you. Thank you for watching and listening.